Okay, my presentation today, instead of doing that same sort of strategic level presentation that Dave did, that's sort of looking at what's next in BIM, what the government strategy is, I thought maybe I'd go back to basics a little bit and just show sort of seven key cool things about BIM, starting right at the basic level and moving a little bit more complex as we go through. So the 7 things we're going to look at in the next, say, 20 minutes or so is visualize. Dave talked about geometry and then more importantly the information. But let's start with the sort of visualization, the geometry side. And then coordinated design. If you think design is putting together drawings, we'll have a little look at that. And then not just the design of the geometry, but the space, the interaction between the objects, analysis, specification, coordinated information across the models, and then finally how that information flows through construction in use. So we'll look at these little 7 areas over the next 20 minutes. First thing I'm going to do is just show a little video to illustrate the visualize side. This was the video that was playing when sort of came in. And this little movie's been put together from one of those sort of 3D models that Dave talked about. And the quality's sort of incredible, and it allows to actually visualize the building before, like maybe it's at that concept design stage. So you've got advantages there right across, like sharing the vision amongst the project team, also sharing the vision to the client, selling the dream, winning contracts. That's just an amazing thing that's sort of possible now at relatively low cost, as opposed to sort of trying to win bids 5, 10 years ago. And then the client can take those sort of visualizations, that dream, and then sell it to future occupiers. So if you've got a large office block that you want to rent out on contracts for the next 10 years, you can start getting that in prior to the building getting built. And you can also maybe share what the building's going to look like to the local community, so they can see the sort of building that they're getting built in their area. So there's just it's a bit of a superficial benefit of BIM, but the visualize side, you can watch that whole video on our website. The link is in the presentation. But moving from visualizations, moving on to coordinated design. So when you think about coordinated design, how that was done in the old days was people on the drawing boards, and you'd have to coordinate all of the different drawings that communicated your design together. And you made one change in one drawing, you had to then update it on all of the drawings, and then different consultants as well. So what we've got a picture here is one of the BIM design tools, and you can see 2 drawings that are side by side, both showing the same door on the same floor. And the fantastic thing about these sort of tools is you change the configuration of the door in one of the drawings, and because it's coming from that central relational database, it changes it in the other drawing as well. So I've then changed it from opening outwards to opening inwards, opening from the left to right to left. And that's the sort of thing that's so easy to make a mistake if you're working in sort of traditional CAD. Delete the door, it deletes it from all the drawings, all the schedules, all the sections. So making sure that the information that comes out of that single model is coordinated is sort of fantastic in terms of efficiency and also quality of information that comes out. So moving on to the next sort of third great thing about BIM, or cool thing about BIM, and we look at space usage. So we have a little look here. We've got 2 generic boilers that have been put into a plant room. And that might be at an early stage. You don't know what the manufacturer is of the boiler, you just know the building of this sort of size needs 2 boilers. And it's not just the boiler itself, that could just be a rectangle cuboid on the wall. It's the space around these MEP objects, because you're going to have to go in and maybe change the heat exchanger. After 5 years, the boiler might be faulty, you've got to take it off the wall, and you've got to be able to get around. So these particular BIM objects there from MBS, we consider the space around as well. So you can see a clearance zone. And that's been done researching the sort of leading manufacturer recommendations out there. So the service engineer can get the model from the architect, the structural engineer, and put the services in that are required, but check that the space allowances are there. So you can see that boiler's too close to the wall, you move it a little bit, you move the other boiler, and you can get that right sort of space requirements for operation inside the various plant rooms. If you look at just a trivial model here, just with some other the MEP objects, again from National BIM Library, so free resource to industry, We look at the transformer, and if that's got a dedicated room in the plant room for the liquid immersed transformer here, again from the basic regulations and standards for the UK, not for United States, not for Australia, not for Far East, there's a sort of 1 metre service zone there that can be indicated around the transformer. So the sort of space that's needed so one person can safely operate the transformer whilst maybe one of his colleagues sort of comes behind. And you can see there the plant room's not quite big enough for that transformer. So you'd maybe want to send that model back to the architect and get them to sort of move the partition wall a little bit. Maybe a slightly sort of smaller object there. Again, it could be just the geometry is not the most important thing here. There's a little sounder on the wall. And what you can do is just toggle a little option there, and you see the sort of symbols that are typically used by consultants in the UK to indicate service engineering devices that are reasonably small. So you can imagine you zoom out of that floor plan a little bit, you can scan across the spaces there and see exactly where the sounders are. And a final example here, sort of staying on the engineering theme, here we've got a point heat detector in the space, maybe in the plant room again, and you've got the little symbols again, you toggle on and off. So here we've got a heat detector with a fixed detection rate, or maybe a rising one. So in a boiler room, you'd maybe have a fixed point heat detector, and you can indicate that there. And also the area around, that sort of a coverage diameter. So I think, again, in the UK, British standard indicates, I think, it's a diameter of something like 10.6 metres. So you toggle that on, and you can see how many heat detectors you need for that particular space. And probably you need maybe two heat detectors for that plant room. So we've had the visualizations, we've had the coordination of the geometry, and then a little bit around the space required around the geometry. Again, staying more on the design side, analysis of the information. So if you look at any of these sort of 3D BIM objects, not just about the geometry, but inside there's a lot of information, a lot of properties, and those properties actually relate to each other. So parametric ones, so if you change the width of the door gets bigger. But more complicated than that, you can have mathematical parametrical equations. So the most simple one you can think about is you could have a parameter for the area of a door, and you could say the area is equal to the length times by the width. So you can't change the area, but you can change the length and width and watch the... So there's some quite complex parameters there about door leaf width thickness and structural opening width, and you can just see those mathematical equations on the right-hand side. Over and above that, you have performance properties, as defined International IFC 2x3, and operational parameters, as Dave was mentioned with Kobe. Things like who was the manufacturer, what's the model, where's the installation manual, operation manual, expected life, etc. So you could take some of those performance properties. For a door, you might think of it in terms of acoustic performance, fire performance, and the little numbers you can see on the drawing here, the number 60, they're actually coming from the properties inside the 3D model. So that number 60 indicates a fire performance of 1 hour, 60 minutes. And there's a little bit of color coding here on the analysis to say everything that's 2 hour fire rating turn red, everything that's 1 hour fire rating turn blue. And if you think of the UK regulations around a kitchen space, approved documents for fire safety, it's a 2 hour, so a commercial kitchen, 2 hours fire safety for all the elements. So you can quickly see that those doors, those internal double swing doors, haven't got the correct fire ratings. So you visually see that through the colours, through the numbers, highlight them, change them to 120, and you see the colour turns red. So you could then show that fire safety officer to the client. They can scan through that fire drawing and see that all of the different fire ratings, the various escape symbols. So you see the exit sign, as you see over our fire exits, oversized in 2D plan, in line with things like heat detectors, sounders. And then again, building on one of Dave's points, it's not just about the information that's trapped inside those 3D objects, but the whole wealth of information across the project team. That includes specification, includes cost information, environmental impact. And if you look on the specification side, the leading specification products out there are now object-based as well. They're not objects you can see in 3D. but they're objects that have got property sets and are related to other objects. So what we can see there is a specification for low temperature hot water system. And before thinking of any of the products, maybe you're not getting paid to design any of the products, you can actually design the overall performance of the heating system. So you can see here I'm invoking specification clauses for the performance of the heating system, for the quality of the design, for submittals. And then at the bottom of the heating system, there's also specification clauses, objects with property sets, to talk about system completion. And when Dave talked earlier about soft landings, making sure the client gets the best possible building for their money, it's all about specifying the correct performance. And then, if we look at the little clauses here for system completion, it's about commissioning, performance testing, so test that that performance has been met. It's about demonstrations, so the client can actually use the heating system, inspections, test records, documentation, operating tools, services and maintenance. And that's the sort of thing when consultants are working for the client, they want to really get nice and tight in their performance spec and model that information. So make sure that the designer working for the contractor gives the best building possible. And that's true for service engineering, architecture, structural, and landscape. You can also use these specification tools to pick all of the individual products. So come across here and pick a particular sort of fan convector, radiator, towel rail, and specify that generically. But then sometime down the line, someone's going to pick a manufacturer's product based on the generic specification. So I could specify a particular boiler through its heat output, it needs a flume on the top, it's got to have certain seasonal efficiency. And then at some stage, somebody, whether that's contractor, subcontractor, or even right at the start, the client, somebody will pick a manufacturer's product. And here you can see the Econoflame R30 Stokefish boiler is getting added to the specification. So 2 more cool things to go. This is coordinated information. So we've got a great property set information built up in the specification. We've got fantastic stuff over in the design model. How is that information coordinated? And what you can do here in the UK, there's a little plugin for many of the design tools. Our company, MBS, has got a plugin for AutoCAD, Vectorworks, Autodesk Revit. Is through that plugin, you can actually link information in the design model to the specification, to the guidance, to the standards, to the regulations. And this is something in the UK that we believe we are real world leaders on. We watch what's happening in Australia, in America, in Scandinavia, and nowhere else in the world has got the link between specification guidance and the design model. So we're looking here, the users click the boiler. On the plugin, they ask for the technical guidance, and you can see all of the design guidance for boilers. So what we got there, we've got the BIM design checks, biomass fuel steam boilers, regulations and bylaws, environmental issues. And this is the information that designers need at their fingertips. And through the combination of quality UK information linked with leading international software packages, that information's at the designer's fingertips nowadays. So there we go, we can click on the BIM design checks and go straight to the BG4 document. And it's not just about feeding information into there, it's about coordinating the information. So in the specification here, we changed the point heat detector to a A1 classification. Annotated on the drawings, the titles may not match, or it might have been removed from the spec and no longer be in the drawing. You can ask for a report, and it flags up where the problems are. So it's not quite as seamless as you change it in one drawing and it automatically changes in another, but the information's getting flagged up. So the architect has changed something in the spec, the architect technician working in the design package has now got a report of that. They can have the conversation and just push that information through. So if you watch what happens to point heat detectors on the right, the title comes through and coordinates, and you've got no further problems. So you haven't just got the specification and the design model coordinated, you've got the objects coordinated within those 2 models. And where we're working on is taking it to that next level. So it's not just the objects, but it's the properties inside the objects. And we're not talking about putting all the information in that single geometric model, but you do want the key information there that will help you with analysis and help you with things like instance schedules, door schedules, radiator schedules, mechanical equipment. So let's look at the schedule here. And we can see we've got the 2 boilers, type A, type B. It's got their property sets. Over in the specification, this is probably where you want to make those decisions. So what are the NOx emissions? You read the technical guidance, read about the BREEAM Assessor's Manual, and you want to drop 70 milligrams down to 40 milligrams. You make that change in the specification. Now you've got a problem because that's incorrect with what's in the design model. And that's always been the case if you were doing a drawing and a drawing board and a spec on a typewriter, but you've never had help before. But now with BIM, now with the technology that's available, following the right process, you can click on that report, and here it's telling you 40 milligrams in the spec, 70 milligrams in the design model, what do you want to do? And you can make that informed decision, and it's pinpointing and highlighting it to you. Pull that up, and all the information is now coordinated, not just at the model level, not just at object level, but at property set, at the real technical information level. And then finally, checking on time, information flow. So the seventh cool thing that I personally think there about BIM is not just the information at design time, and this is probably the most important, the information flowing right through construction, handover, in use. And the way I talk about this is maybe a little bit oversimplifying it, but if I was writing a document in Microsoft Word, there's loads of amazing functionality. I can do mail merge, track changes, add comments, and I can use whichever package I want to write my document. But when I want to issue it to somebody else, I want that document to be, Microsoft might go out of business in 5 years' time, be overtaken by Google or Adobe. I want that to be in a format that any other software can read. So I export it to PDF, and the client can have free tool, Adobe Reader, and read all of that information. It's still got its structure, its table of contents, its hyperlinks. And crudely speaking, construction have that same principle, because you can export to a format called IFC. So here's exactly that same model, and the information from design tools like Bentley, Allplan, Vectorworks, AutoCAD, our sponsors, Autodesk, can be pushed into this IFC format, and also from things like the specification tool. So you're getting all of that information into an open source format like the client can query. So what about that boiler? What's its spec? What's its installation manual? What's its operation manual? And that's there at the client's fingertips now. And the speed that technology is advancing, this is sort of stuff you can get on your iPad now. You could go around the building, say, which room am I in? What's the operation manual of this boiler? I've got to change the heat exchanger. And that information's at your fingertips. And it's not in a series of 5 boxes that are down in the boiler room, which have got wet because the boiler room flooded. It's there digitally in a robust format. And more advanced, so intelligent clients can query this IFC information any way they wish. So give me a report on all the doors and the different fire ratings, acoustic ratings, what rooms they're in. And there's that report coming off IFC, open standard format. And then finally, Dave talked about COBie. And in fairness, it's a hard subject to do justice to in about 30 seconds. But COBie is that standard, almost dumbed down format of IFC. So you've got the IFC model at the top. And at the bottom, what you've got is the COBie defined data set. And in its most simple terms, what you can see on the screen, it's a building that's if you look at the little worksheets, it's facility properties, how many floors, how many spaces on each floor, and then the components in. So you can click on any of those little worksheets. It's attached to a relational database and see that important information in an open standard format that's not tied to any one software vendor, whether that be NBS, Bentley, Autodesk, whoever. Open format data for the client in a rich digital form. And that essentially is the government's strategy when it comes to BIM. Let the market compete on the best products, but at the end of the day, we want it in an open standard format for our FM systems. So, in summary, just about on time, BIM is happening. Clients, designers, contractors, as you're going to see today through some fantastic presentations, are using BIM now. What we're looking at there is in the market now. That's not future gazing in 10 years' time. This is happening by the leading edge of UK construction. And why is this happening? It's happening because it's a more robust and efficient process. And it's a more robust and efficient process right through the project timeline. If you get a chance, go and download the new RIBA plan of work, which talks about that information flow from strategy to preparation through the different design stages, concept developed, technical, construction, and you can use that BIM process all the way through. And there's plenty of free support out there to help you on your journey. I'll just leave you with three websites. Reinforce Dave's point, bimtaskgroup.org. Fantastic website. Please add that to your internet bookmarks. Our own website where I work, thembs.com/BIM. There's loads of free video presentations, case study articles. We do a national BIM report every year. So thembs.com/BIM. All the resources there are completely free. And then finally, the objects I've been demonstrating today all come from nationalbimlibrary.com, which is funded by manufacturers, because manufacturers want their objects on there. But the great news is it's completely free to UK industry. And there's objects there that are concept objects. There's objects there that are detailed but generic, where a manufacturer hasn't been mentioned. And we're getting an increasing number of manufacturers coming on board now with their actual objects, with their information inside. So I hope that was roughly 25 minutes, but 7 cool things about BIM. Thank you very much.